Alright, so the first thing you want to do is label your triangle. I'm going to label it A, B, C. And then the next thing we know are these two sides are congruent because it's given it's an equilateral triangle, so all the sides are congruent. And it's also an equiangular triangle. And I'm just going to draw an altitude, which is going to bisect this side in half, which then makes these two angles 30. And since this was an equiangular triangle, we know these two angles are congruent because they were cut in half by an altitude, which is the same thing as, well, almost the same thing as a bisector. So it just cuts it straight in half. And then we need to prove that these two triangles are congruent, and we can do that by SAS, because x is congruent to x, so that's a side argument. The 30-degree angles are congruent because, again, they were chopped in half by an altitude, and this is a shared side, and it's also an altitude, so it cut the triangle directly in half. We also know that at the base of a bisector, there's two 90-degree angles, but that's not relevant for our argument. So by SAS, A, B, X is congruent to C, B, X. Now, we know that since this side has been chopped in half by a bisector, the base, that this would be x over 2. This would also be x over 2. So, we now just have to do Pythagorean theorem because we did nothing with this side, cut it or anything, so it's still just x. So we just have to solve for this side right here. And let me erase that. Alright, so our problem would look something like this. BD squared plus x. Why did I say BD? I'm sorry. In my old one, I labeled XD. Sorry. BX squared plus x over 2 squared equals x squared. Alright, we have that. Now, we're just going to do Pythagorean theorem. So, bx squared is bx squared plus x squared over 4 equals 4x squared over 4. This is still the same thing as x squared because 4 divided by 4 is just nothing. Yeah. Alright. Moving on, we now have to get rid of one of these. So x squared over 4 minus 4x squared over 4 would equal 3x squared over 4. So now we know bx squared equals 3x squared over 4. And now here's where I get a bit lost because I kind of get it, but the Khan Academy guy was talking about principal roots, and I don't think we got it. Like, we were taught about that, but what you're supposed to do apparently is bx would equal the square root of 3, because the square root of 3 is the principal root of 3, and x times x, or just square root times x, because x squared's principal root is x, over 2, because apparently the principal root of 4 is 2, and then voila, you solved for this side, and you have now proven the ratios for a 30, 60, 90 right triangle. Ta-da! You did it! Yay!